It's one small step for man, one giant leap for mankind. Oh, that looks beautiful from radio. It has a stark beauty all its own.
Historical development of the solar system model. Ptolemy, a Greek astronomer, astrologer, and geographer, built the geocentric model with Earth in the center and circular orbits. Geo means Earth, centric means center. Earth is the center of the solar system. Earth is stationary, and all the objects such as the Sun and the other planets that revolves around Earth is circular. Copernicus, a Polish astronomer, mathematician, economist and doctor, built the heliocentric model with the Sun at the center and circular orbits. Helio means the Sun. Centric means center. The Sun is at the center of the solar system. Earth rotates in its axis and revolves around in a circular orbit. Kepler, a German astronomer, mathematician, and astrologer, modified the heliocentric model with the Sun at the common focal point, elliptical orbits of the planets according to Kepler's law.
If you watch the stars at night, it appears as if the stars are moving, that the Earth is completely still. This is an example of apparent daily motion, and was used to justify that the Earth was the center of the universe for many years. Welcome to Moo Math and Science and the geocentric and heliocentric models of the universe. From the perspective of the stars moving, it is very easy to assume that the Earth is at the center of the universe. This was the accepted theory called the geocentric model for many years. Great minds like Aristotle and Ptolemy proposed and supported this view of the universe. Geocentric means Earth-centered, and it just seemed right. However, there were some problems. For example, sometimes the planets appear to be going backwards or to have a retrograde motion. In order to explain this, small orbits called epicycles, which are orbits inside the orbit, were proposed to help explain this backwards motion. This model of the Earth being the center did not sit well with Copernicus, and in 1543 he proposed On the Revolutions of the Celestial Spheres, in which he explained what many had suspected, that the Sun is at the center of the universe, and that we move on Earth along with the other planets around the Sun. This is called the heliocentric model. He proposed that each orbit was a circle, and the Earth, like other planets, revolved around the Sun. This solved several problems, including the retrograde motion of the planets, arguing that such motion was only perceived or apparent rather than real. With the help of his telescope, Galileo Galilei discovered the moons of Jupiter and observed that small objects revolve around larger ones. Johannes Kepler proposed that the orbits of the planets were not perfect circles, but ellipses. Our planets travel in an ellipse and actually speed up when closer to the Sun and slow down when further away. The retrograde motion of the planets was explained because it is caused by the planets that move more quickly past other planets, and it appears that the planet is going backwards. Sir Isaac Newton proposed his laws of motion to help explain how objects interact with the world and each other, and his laws of gravity identified the responsible force behind celestial motion. We now know that the Sun is one of many stars and is not the actual center of the universe, but the planets do revolve around the Sun and not the other way around.
Development in space exploration. It all started in the 11th century. Chinese invented gunpowder and used primitive rockets in battles. First telescope used in the field of astronomy by Galileo Galilei. In 1957, first satellite was launched by USSR Sputnik 1. In 1961, first human to orbit Earth, Yuri Gagarin aboard USSR Vostok. 1969, first human to set foot on the moon, Neil Armstrong, US Apollo 11. In 1973, first Jupiter flyby, US Pioneer 10. In 1981, first flight of US Space Shuttle, Columbia. 1989, first Neptune flyby, US Voyager 2. 1990, US launched Hubble Space Telescope from Space Shuttle Discovery. 1996, Malaysian satellite MESAT 1 and 2 launched. In the 2000, Malaysia's first microsatellite Chong SAT-1 launched. In 2002, National Space Agency, Agency Angkasa Negara, established. In 2011, construction of International Space Station ISS completed. Space Telescope. Application of technology in space exploration and their importance. Astronomical sextant. It is used to measure the altitude of the stars. Galileo's telescope. It became the most widely used astronomical instrument. Hubble Space Telescope. Hubble Space Telescope was placed in an orbit 500 kilometers from the surface of the Earth. Spitzer Space Telescope. This specific telescope detects very distant activities in space. Radio telescope. Apart from optical telescopes, radio telescopes are also used to detect radio waves from space. Rocket. Used to send humans to space. Rockets are used widely in space explorations. When the fuel in a rocket burns, hot gases are released at high speed through the bottom of the rocket. The release of these gases produces a force which pushes the rockets upwards. Development in space exploration. In 1957, Sputnik 1, the first man-made satellite launched by Russia into orbit around Earth. Also in 1957, Sputnik 2, the satellite carrying a dog, was launched into orbit. Whilst in 1961, Vostok 1, the Russian spacecraft carrying Yuri Gagarin, orbits the Earth for 108 minutes before returning to Earth. In 1969, the United States spacecraft Apollo 2 landed on the surface of the Moon. Astronaut Neil Armstrong and Edwin Aldrin set their foot on the surface of the Moon. Lastly, in 2007, Dato Dr. Sheikh Muzaffar bin Shukr, the first Malaysian astronaut to space. How does a satellite work? The above picture shows how the satellite operates its function in the field of communication. The waves from broadcast stations on Earth are transmitted, and they will be accepted by satellites. These satellites amplifies the wave and transmit it back to a certain place on Earth. This allows us to listen to radio or watch television broadcasts from other countries directly. The use of satellite is divided into three types: A. Navigation and positioning, B. Remote sensing, and C. Communication. Facts about satellite. Fact 1. The very first satellite Sputnik 1 by Russia had a very small size, which was like a football, and it was floating on the Earth's orbit. The Sputnik 1 was giving sound of beep, beep, and it continued to be like that for 21 days. Fact 2. Every day, satellites transmit and send a huge amount of information back to Earth. If all the data that one sends in a year would be saved on DVDs, then the DVDs could form a stack the height of nearly 4 times height of the Empire State Building in New York City. Fact 3. There is a satellite orbiting Earth that is predicted to re-enter the atmosphere in 8.4 million years, carrying a message addressed to the human beings and civilization of the future. Fact 4. When the Skylab satellite crashed in Australia in 1979, Australia issued the US a fine for littering. NASA didn't pay the fine. Fact 5. NASA has 2 satellites chasing each other around the Earth, tracking the distance between them to measure gravitational anomalies. Their nicknames are Tom and Jerry. Space probes. It's a robot launched to explore other planets. Probe can orbit and land on a planet. It carries different kinds of science equipment to photograph photos, detect radiation emitted by objects in outer space, measuring surface temperature and tracking the magnetic fields of the studied planet. Its movement is monitored by the control center on Earth. All information collected is sent to Earth in the form of radio signals via radio telescopes. Remote sensing technology. Remote sensing technology involves the study of Earth from space. There are 2 types of remote sensing, which is active remote sensing and passive remote sensing. Remote sensing satellite records data and its images displayed on the computer screen. This technology is widely used in agriculture, geology, meteorology, disaster management, and so on. Conclusion. We need to continue space exploration because it allows us to better understand the universe. Space exploration also benefits to the advancements of the aerospace industry in our country. In 2001, Malaysia successfully released its first unmanned surveillance aircraft. Space exploration is important to, first, obtain detailed information on Earth, planets, and space objects. Second, produces several types of pure and high-quality materials such as microchips, crystals, and special metals that are not available on Earth. Third, review the construction of power plant using solar energy in outer space. The generated energy will be sent to Earth. Fourth, find new placements for humans in outer space. The end. Thank you.
What is it? We have some explanation for that. We have some. Don't worry. Continue your program. Oh boy, it's really something super fantastic here. You couldn't ever imagine this.